Alright, so in today's lesson we're doing parts of a circle. So I've put the diagrams, 2 circle diagrams, which have got all the different things that you need to know about the different parts of a circle. So on this first one, we have a centre point right in the middle here. So that is the centre of the circle. The straight line going from the centre to a point on the circumference of the circle is called the radius. Now you probably already know that, but we've got to make sure that you understand all these terms. The line that goes through the centre and goes from one point on the circumference to another point on the circumference and through the centre, a straight line, is called the diameter. Now then we get to things like this. Now this looks like a piece of cake or a piece of pizza that you've cut out of a whole pizza or a whole cake. Okay, so you would cut into the centre and back out to form the slice that you're taking. That slice is called a sector. Okay, so make sure you understand that sector. Alright, now the curved part that goes from a point on the circumference to another point on the circumference, so in other words it is a part of the whole circumference of the circle, is called an arc. Alright, and you probably know that an arc is a curve. Well, that's the curve it is. It's part of the circumference of a whole circle, joining 2 points on the circumference. Okay, now we'll come over here to this one here. Now this little slice here, if you just cut a piece off the edge of something like that, that is called a segment. Okay, so sometimes they might talk about orange segments or something. So you're cutting it off the edge, okay, just like that. Now the straight line that you're cutting, which joins from a point on the circumference to another point on the circumference, straight line from one point on the circumference to another point on the circumference is called a chord. Notice that's a bit different to an arc. They're both joining from one point on the circumference to another point on the circumference, but this one's a straight line and this one is a curve. Okay. So this little piece inside here is called a segment. So sometimes people get sector and segment mixed up. So just be careful with those two. Alright, now down here I've just tried to show you that the circumference is all the way around the circle. It's what you actually draw when you're drawing a circle. You're actually drawing the circumference of the circle. Now if I look at this piece here, if you got a pizza and you decide to have that big piece there, where you're actually cutting a right angle out of it, that's called a quadrant. Alright, because quad we know has something to do with 4, it's a quarter of the circle. Okay, that's why the 4's involved. Quadrant, 1/4. Okay, and this piece here, which is, there's a diameter which cuts it straight into half, that is a semicircle. Semi means half. So it's half a circle. Alright, so over here we have a little bit of information about circle symmetry. So in year 7 you did 2 types of symmetry. So one of them was about axes of symmetry, which you've done back in primary school as well. So if we look at a circle, it actually has an infinite number of axes of symmetry. So all an axis of symmetry is a line that we can draw on this shape so that one half of the shape will reflect onto the other half of the shape. Okay, so if I have a look at, I'll just draw it down here because I want to show you 2 different things. So here's my circle. If I get my red pen, I can draw straight through there. Now I've created 2 semicircles, but you can also imagine if I fold along that red line, the semicircle will fold on top of the other semicircle. Okay, so that's an axis of symmetry. Well, I don't have to draw it in that spot. I could have drawn it here, couldn't I? And I could have folded it there and it'd still land on top of itself. I could have drawn it here. I could have drawn it here. I could have drawn it here. And as you can imagine, if we just keep drawing, we can draw lots and lots and lots of diameters to split it into 2 semicircles that will fold on top of itself. So there's an infinite number of those red lines an infinite number of axes of symmetry, an infinite number of diameters that we could draw that would help one semicircle fold on top of the other semicircle. Okay, now the other type of symmetry that you've done before is called rotational symmetry. Now rotational symmetry, I'll just draw our circle again. So with rotational symmetry, we have a centre of symmetry. So this would be the centre of symmetry. I'll just write of symmetry down here so it's not in the way. And what we're going to do is spin the circle around that point. So what we want to know is when you spin it, so if I give you a different shape so you can understand what I'm talking about. So if I have this, right, that's a rectangle and I've got my centre in the middle there. Now I want to know when I spin it one whole, or if I spin all the way around, that shape will come back on top of itself. If I spin all the way around 360 degrees, we know it's going to come back to itself after a 360 degree spin. But what I want to know is how many times we can spin within the 360 to make it still look like that. So for this one here, if I spin through 180 degrees, that shape will still look like itself. I'll just show you with a piece of paper. Right, so we're looking at a piece of paper. If I put the centre in the middle, like that, right, I'm going to spin it around that point. So I'm going to pretty much hold that still. Now, you've got to tell me when it's going to look like that again. So watch, I'm going to start spinning. I've spun 90 degrees so far. I've spun 180 degrees. Now, that looks exactly like it did a minute ago, and I've gone around 180 degrees. We'll go again, 270 and 360, and now it looks like itself again. So in that one, we would say that it has rotational symmetry of order 2 because it goes once for 180 degrees, twice to 360 degrees, looking like itself. So that would be rotational symmetry of order 2. But with a circle, we want to know when we have a circle. If we spin it, I'm just trying to see if I've got a circle here. I'll have to just look at one of these ones, I think. All right, so just imagine that this is a two-dimensional circle that we have here. So if I've got that in the middle there and I start to spin, we're just looking at the red circle here at the front. So if I start to spin it, my red circle looks the same all the time. There's no point where it doesn't look the same. So I can spin it through 100 degrees, 240 degrees, it doesn't matter. It's still going to look like the same circle. So that means no matter how many times we spin, when that holds still and I spin this circle, the circle's still going to look the same. So that means it's got an infinite order of rotational symmetry. Okay? All right, now I'm just going to look at one question here. This is an ellipse. You might have learnt that it was an oval shape when you were in primary school. We don't call it an oval, we call it an ellipse. It's not an eclipse. An eclipse is when you have a solar eclipse or something where the sun is being covered by something, might be a total solar eclipse or something. This is an ellipse, 2 L's. Now, this first question says, how many axes of symmetry does it have? So, if we try and just draw this shape again, do your best. Now, how many axes of symmetry does it have? In other words, how many lines can I draw to make this fold on top of itself? Well, here's one of them. If I fold along that line, that top half will fold down onto the bottom half. And here's another one. If I folded it along there, the right half would fold on top of the left half. And that's the only two that we have. So we say it's got 2 axes of symmetry. If you tried to fold it anywhere else, it's not going to fold on top of itself. Okay, now the next question says, what is its order of rotational symmetry. So let's look at this ellipse again and put the centre point in. Now, remember what I said before, so we're going to spin around the centre. So when we start to spin this shape, right, we spin it to 90 degrees and it would look quite long. I'll actually try and draw it here for you. Okay, so we've got something that looks a bit like an ellipse here, right? So watch what happens when I start to spin. So I'm spinning 90 degrees. That doesn't look like it started, does it? Spin 180 degrees. Now it does look like what it's supposed to, so that's 1. Spin 270 degrees. It's back looking like an egg shape, isn't it? Spin 360 degrees and we're back to where we were. So it has rotational symmetry of order 2. So it's a little bit like what happened when we looked at the rectangle before. Okay, so it is, when you spun it around, when you did a 180 degree spin, it looked like itself. And then when you spun it again, right round to 360 degrees, it looked like itself. So it's order 2. Okay, so that's all I'm doing on that because the questions that you're answering are all based mainly on this work here, knowing what is what. Okay, so you're going to be doing your homework based on that sort of thing. But I'm going to be doing in our next video for today's lesson the circumference of a circle. So coming back in the next video to do circumference of a circle.